So here's a general rule of thumb to decide if the trapezoid rule gives an over or an underestimate. So let's say that you wanted to find the area that is under this curve but above the x-axis. And in order to do that, let's say that we had a bunch of trapezoids that would give us an approximation. So let's just say that we had 4 trapezoids for this particular problem. Now, notice that the original problem, the purple function, was concave up. Let's just call it CU for concave up. Whenever it's concave up, here is what's going to happen. So with all these endpoints, let's actually connect them to construct our trapezoids. And notice that because the graph was concave up, we are going to include not only this here, and not only all of these parts here, but we are also going to unfortunately include these parts there. Check it out. You see this part that I'm shading in? That is not underneath the purple curve. So we are including extra area that really shouldn't be there. So whenever we have a graph that's concave up, we're generally speaking going to be giving an estimate that is an overestimate because it's more than the actual graph. It's all of the graph, all of the area included, but it also includes these extra pockets that honestly should not even be there. So when the original graph is concave up, generally speaking, it's going to be an overestimate. Now consider a graph that is concave down. Here, when we create all of the endpoints, watch what happens when you connect all of these points together. And now if we shade in the green region, so you can see here that all of these green trapezoids, they really do capture the majority of the area that was under the purple, but there is some residual material that unfortunately is left behind and that the calculation does not account for. So that pink is missing. So whenever the graph is concave down, we typically speaking say that the estimate is an underestimate because there are pockets that are missing in the estimate.